So what we're going to basically be doing is now we're going to get into a little bit of the discussion and basically ponder over just how this study has shown us, regionally as well as globally, that enterprises obviously must consider the edge from a data storage perspective, including seamless data movement, data storage, and security. So globally, what challenges and opportunities will companies face when looking to strengthen their edge capabilities in 2019?
I think it's really three things, right? So when you think about the challenges associated with rolling out the edge, the first one is maintaining it. Having a physical presence out there in a remote area where you've got a server or something connected to a pipeline, how do you make sure that that is still working? How do you make sure that it's updated with the right patches so that it's doing what it's supposed to be doing, and that the electricity is on, that it's cooled and properly maintained? That's probably one of the biggest challenges. The next challenge is the new types of data that are going to be available to you at the edge. You're going to be able to capture data that you've never captured before. How do you manage that data compared to the data that you used to use, right? So how do you infuse that in there? How do you extract the value from that? That's certainly some of the challenges I see. Maybe some of the opportunities is, I think you get to control the customer experience. If I can have an effective edge out there, then now I get to engage my customer, whether it's business or consumer, in unique and exciting ways. And if I can do it better than somebody else, then I get to own that customer experience. I mentioned capture new sets of data, but there's a whole new area of what we call OT, operational technology. We've been doing IT for years. OT is that connected elevator that's sending information to you. It's the connected refrigerator, the connected washing machine in my house that's sending information to a manufacturer. It's a new source of data. It has different access privileges. It has different security protocols, and trying to make sure that you manage that is not just a challenge, but it's a huge opportunity to drive new levels of service and convenience to the users.
Yeah, I completely agree with that, and I think that's one other thing that I'd like to point out as far as challenge is concerned, and that's security. I'm sure that many of you have visited data centers, and as you actually get into the data center, the security around the data center, around the four walls, is probably even tighter than that of a prison. So imagine now you've got how precious and how important the data is, and then now you're going to have the data all at the various edge sites. Now, are you able to secure the data the same way as you would the data centers itself? Now, that's obviously the types of data that you store at the edge will be different for the data center and the core itself, but still, it is a very, very big question and a challenge a lot of enterprises will have to take into consideration. So how do you secure the data at rest?
Yeah, that's a great comment, and I would just maybe build and not repeat on the security comment, but if you go one level down to security, Dave, I want to build on your comment about where data is positioned, because as we think about the edge is a tiering of data. There's the traditional data center in the core that you've talked about, and we've talked about tiering within that data center, but as the edge comes online, to BS's point, you're going to move those tiers outside of the traditional data center into other locations. So not only do you have to worry about the security, you have to have some group at your company or part of your entity that's thinking about what data do I want at each point of that access. Because you don't necessarily need to have all the data flow to the edge, flow up to the core. There needs to be an intelligent thinking about where the data is and where we're going to extract value from that data, either at the edge or at the core. And there needs to be a group that's thinking about it and positioning the company or the entity architecturally around that.
I've been following Seagate since the year 2000. I've been with IDC going on 19 years this year. We get a 20-year trip. We get to go anywhere in the world. So I hope I make it one more year. It'd be really great. But I've been covering Seagate. I started out at IDC covering hard disk drive. Seagate started them back in 2020. The year 2000, I worked for a company that supplied critical component, Hutchinson Technologies, who's now TDK, for many years prior to that. But my question to you then is, how have you seen the data center change in the age of edge computing? Where do you think the roles for the data center, the core, is going to go now that the edge is starting to proliferate and expand its role and presence.
I think this, I'd answer it this way, right? When you talk about data centers, I look at it from a private cloud versus a public cloud. So I'll touch on both. I think, from a public cloud perspective, what has changed right now is two things, right? One is there's a proliferation of data centers spread across all the various geographies. That's in part due to legislation, because certain countries want to have data in country. And secondly, it's due to the scale, obviously, as the scale grows. And then thirdly is latency as well. So we see that happening in the public cloud space. And then on top of that, what we see is that the public cloud service providers are now moving to offer edge services as well, right? So it's not just about the public cloud operators offering core data center services, but they're also extending out because they too recognize that there's a need for edge infrastructure, and they don't want to be left behind. Now, on the private cloud side of things, I think a lot of enterprises right now are moving into a hybrid IT model, and so it's not just I want to have my own data center, but it's more about having their own data center, and also how do we bridge that to the public cloud as well. So that becomes really interesting. In fact, surveys have shown that majority of the companies who are thinking of moving into public cloud will have a degree of will retain a degree of their own data centers as well.
Yeah. Maybe just to build on a few comments you talked about there. And first, we talked a lot about latency and the importance of real-time data in terms of how we structure or architect our data. But that's not the only driver for the edge, and you mentioned a couple other ones that we got to stay focused on. The other drivers to talk about are size of data, and that's kind of correlated with cost of data. It's not free to move data through a pipe from endpoint to edge to cloud. It costs money to send data through that pipeline.
Yeah.
And so the idea that you should really only be moving data if you need to move the data based on how you've architected how you get value out of the data. So that idea of don't move the data unless I have to move the data is something you should be thinking about. And then the third element that you captured, BS, was compliance. Compliance either due to privacy reasons or compliance related to localization of data. There's a lot of different drivers beyond just this idea of real-time data, and all of those factors, depending on your company's situation, have to be part of that decision-making process.
Yeah, you brought up some interesting comments, and I'll kind of add to what you're saying. Data has mass, right? So so therefore it doesn't move cheaply. If you think about, say, a connected vehicle, even an airplane. I mean, we've had these airplanes that they get lost, and they can't find them anywhere. And you would think, it's like, well, why aren't they just constantly communicating location and all the stats across the connection that they have in the whether it's satellite, whatever, because it is just cost prohibitive. Instead, what do they have? They have a black box, and they collect all the data there, and assuming you can find the black box after an event, you can then recreate what happened. But it's really hard to do it real time because there's no presence of an edge when you're 35, 40,000 feet in the air. Same thing with an autonomous vehicle. It'd be great to have every vehicle connected via cellular, but it's expensive. So what you're going to have is you're going to have these little gateways at a stoplight so that when your car stops and you're at the stoplight, there's going to be, oh, I can see this car, I'll start unloading the data really, really quick now. Okay, the light's green, I got most of the data, now you're on doing your own thing. So the connectivity is a huge part of the edge. Not just making sure that it's cost efficient, making sure that it's available 100% of the time or as much as possible so that you can deliver these services. One of the roles that I think the data center will have too, and I'd like your opinion on this, is, as I said earlier, you're going to have the opportunity to capture a lot of data. And we use the term data lakes a lot. But the last thing you want is your data lake to become a data ocean or a data swamp, right? Or a data bog, a data marsh. the Dead Sea of data. You don't want that. So I think the role of a data center is going to now start to making sure that data is managed in a very appropriate way and in instead of siloed environments. And that's going to be difficult to do because you're going to be bringing in all these new sources of data, but the last thing you want to do is silo all these data sources, because if you don't intersect data, you can't apply analytics. So how do data centers do that? What kind of infrastructure do they need to bring together to make sure that their data lakes don't become data swamps? How do they go about liberating data?
This is a really important point, right? And I think the public cloud operators have a bit of an advantage because of the scale they have, and I think to the extent that how they manage the data that they're holding, right? Is a big part of their cost structure as well. So as we interact with a lot of these public cloud operators, they spend arguably as much time and resources on optimization, and really how do they optimize the data that they have, and optimization not just to the extent of the data tiers or the that Jeff talked about, but also about how to manage and move the data to the various locations in the most efficient way possible. So one is the public clouds are actively working on that. Now, as far as the enterprise data centers is concerned, I think they don't necessarily have that kind of a scale to do their own development. So then they'd have to really rely either on what's out there, third-party services out there to really help them manage. Because I think within, I think Jeff would be able to comment on it because he manages that in-house. But it's just more of a question of one is how you ensure that you're consistently maintaining the data that you have, and then moving the data to the various tiers of storage such that it's the most efficient way possible.
Yeah, we use a term called data governance in terms of how we try to optimize and re-optimize our data in the system. I want to build on a couple things you captured, BS. First is there are tools that allow you to analyze data across databases or even across data centers. Those tools are out there. We're using them, and that's why this idea of position the data where it needs to be to extract value. You don't have to move everything to a centralized database to do the analytics on it. The second point I want to make, which we're kind of dancing around a little bit because we're talking a lot about infrastructure, but we haven't talked about people yet. And you have to have the people infrastructure at several levels to be able to extract value from the data at all those levels. And let me highlight a few. First, I would say you need people that understand how to analyze data and big data sets. It's no longer a world where there's data up in a database, I pull the data down to my laptop or my computer, I analyze it. That's not how things are done today in a structured way. Data is analyzed at the database, and you need people that can do that. And we call that at Seagate a citizen data scientist. We need the workforce to be able to understand how to do modern analytics on data. The second piece is you need people that are actually building those data pipes at your company and thinking about the architecture of where the data is located. And that would be data scientists and computer scientists. And then lastly, importantly, there's got to be some executive buy-in that data has value. I mean, for big hyperscale cloud companies, data is their value. It's obviously their value. But for enterprises, data in some cases may be viewed as support for their real product rather than necessarily an asset that has value. So there has to be executive buy-in that data is important for how we're going to operate the company.
Yeah, those are great comments. I think about the various applications by industry, and one of the things that we did with Seagate this year is kind of look at some of the industries and how they're prepared to handle the data that's coming their way. We called it the DETCON index, Data Readiness Condition Index, And we did it by a number of industries. And when you mentioned skill set, it came to mind that some industries have a pretty good skill set. I mean, when you think of manufacturing, they've been doing this for years, and they know exactly what to do, especially inside the factory walls. I think what's interesting when it comes to this skill set is, and you mentioned all of them, and probably this is included, but a data visionary. Somebody has to sit there and figure out what is it that we want to deliver to our customers? What is it that we want to deliver to our business partners? And what information do we need, and where can we get that level of information? So I think about the manufacturing environment, and one of the companies we interviewed, they built engines, and they were putting sensors on all their engines now. And as we kind of discussed, it's great to have that information, but what do you do with it, right? But what's so interesting is inside the manufacturing walls, it's a controlled environment. I control vibration, I know what the temperature is, I control who uses it. It's a very, very controlled environment. Once you exit the factory walls, all of a sudden you increase the randomness of what's influencing the data that you're capturing. So as you capture data, it's not just about the fact that you get a hold of data, but you have to understand, is it good data or is it bad data, right? Garbage in, garbage out. We used to say that back in the 80s, back when the PCs, right? It is now so much more important because as you start to enable processes with AI, right? You're trying to build artificial intelligence and algorithms to make sure that you place data in the right place at the right time to deliver it to the right people on the right device in the right format. If you don't get it there just in time or at the right time, then you're gonna ruin your service. You're gonna create a poor customer experience, and then that's gonna spoil the well for everyone else.
Yeah.
And so I think about that manufacturer who is now taking sensor data, and they're now understanding, well, even for refrigerators or washing machines, how often do I leave the door open? How often do I do a load of laundry, and what settings do I put it on? They're using it for maintenance, sure, but they're also beginning to understand how their users are actually using the product. Now they have to figure out how to take that data, infuse it into the manufacturing process to make a product that's even longer lasting with better customer experience and personalized, by the way. And I just think that's fascinating.
I really love your comment about the structure of the data, and you mentioned it briefly, but cleaning of the data.
Yeah.
Because sensor data is not always clean, and once you go down these paths of, I would say, automated decision making, you have to have the right cleaning of that data, or you're going to, to your point, garbage in, garbage out. You're going to make bad decisions.
So you've done a lot with manufacturing.
Yep.
Other industries that you've had experience in, whether it be healthcare. I know for us, healthcare is an exciting industry that we explored, because if you think of the advances that you can do with healthcare, it's kind of like you're taking healthcare, or you're taking IT to the people. So it's tough sometimes to get your child into the clinic or to the hospital. The wait time to get in is terrible. You go there to wait, then you go into a room and wait some more. It's not a good experience. But now you have telehealth, right? The ability to use video and audio to present whatever the ailment is of your child to a doctor online, and get a diagnosis and maybe even a prescription without even having to go into the medical center itself. So that's a really exciting thing that healthcare is going to do. Also, AR/VR. We didn't really talk a lot about AR/VR, but what's fascinating to me is the use of virtual reality in phobia situations. So if you're afraid of spiders, or if you're afraid of heights, or you have this fear of people, they use VR in clinics to basically, they're watching your body metrics the whole time, but they're introducing you to a whole new set of reality to get you to overcome the phobia. And I just find that fascinating. Do you have other industries that you've worked with where there's exciting applications, or that you've had to deal with a limited skill set?
Absolutely. I think you've brought up some really good examples. I think you also talked about, and we talked about autonomous vehicles as well. So that's really exciting. Agriculture is another one that's really up and coming as well. But the one theme that we do see across all the different emerging markets, if you will, most of the discussion really starts at the application level. And what I mean by that is that, they start with hey, what services, can we do, and what are the inventions and the creations, that allow us to perform these particular applications and all of that. But what in our opinion, what not a lot of attention is paid on, right, is the back end and the infrastructure required. And oftentimes it's all about data storage infrastructure and data transfer infrastructure. So I think healthcare and autonomous vehicles are two very, very good examples of that. A lot of focus on the front end, the car itself. What can the car do? But not a lot of discussion about, okay, well, the car just can't operate on its own. It needs an entire infrastructure worldwide in order for the car to operate. Just like in healthcare, you can have all these great equipment out there to do remote surgery and all of that. But okay, well, the robot can do that. But how do you make sure that there's an infrastructure around it to ensure that there's linkage around? That's the part that I think that not enough focus and attention is really being put on based on our interactions with our customers.
Yep.
Yeah, you mentioned the robots in healthcare. One of the measures we do about data in the global data sphere is the criticality of data. We all know what a blue screen is. It's never fun, but it doesn't kill us. What is becoming increasingly important is to understand that there is critical data. Sometimes it's not critical at all. The data associated with the movies that I watch isn't critical. The blue screen creates an inconvenience, but if I have an embedded defibrillator and an embedded insulin pump, and if that data is wrong, then a life's at stake. If the data is wrong in a self-driving vehicle or in an airplane. So the criticality, in fact, the hypercriticality of data is starting to go up. Yeah. And that's really where we see the intersection of the digital world with our physical world. Do we want it? Well, if it brings a level of convenience and a level of efficiency, then yes, we want it. You mentioned autonomous vehicles. Personal experience, I had a car that had these autonomous driving features in it, but the problem was it had the proximity cruise control, where it stayed a certain distance behind the vehicle, right? And that's fine, and it was very convenient, but the problem was it was too far. I couldn't get close enough. So what happened? This guy over here decides he's going to pull in. And that means I come back a little bit. Now another one comes in, and it felt like I was going backwards sometimes. And so what is that? Why do they do that? They have to do it because a life's at stake. They have to build in enough cushion and enough margin to take care of the randomness that exists. So you were mentioning, BS, about the infrastructure around there. If I can create an infrastructure where I can control the variables, and instead of my carpool lane, it'll be a autonomous vehicle lane where I know that the only thing in there is autonomous vehicles, then I can tighten up those distances. I can bring in those parameters and I can control it much more finely and make it a much more pleasing experience and a much more efficient experience. And so that's something we look forward to, but it takes time to roll out that infrastructure, and sometimes there's resistance.
Yeah.
Video surveillance is perhaps one of the largest drivers, has been one of the largest drivers within the data sphere. What kind of activity have you seen? And it's certainly an edge application, right? It's an endpoint, but it's an edge application. What kind of growth have you seen with video surveillance across the APJ region?
Let me start with global, and then coming down to APJ, right? Firstly, within the storage industry, this segment, at least in the last 5 years, is one of the fastest growing segment outside of the cloud and data centers. What is really changing is that it's moving from really being an endpoint application to an edge application, and now also emerging, becoming a core and data center application as well. What we're also seeing is an emergence of a service model as well, and is in addition to just selling the boxes out there. Now, what is different, in the video surveillance space is that the edge infrastructure tends to be, I guess, owned by the brands themselves. I mean, they will provide solutions from the endpoint to the edge, and then also, offering cloud services as well. So that's what's in a way a little bit unique about this segment, because there's a few companies that's offering this end-to-end solutions. Specifically for APJ, we see that as one of the fastest growing segments as well. By far the largest market within APJ for video surveillance is India. I would say that India itself is takes up a very, very significant portion of the percentage of the business in APJ, but it is certainly a very, very fast growing market. And the other countries that have a very, very strong focus in video surveillance would be Taiwan, Korea, and Japan. The rest of the APJ countries are more consumers or and they're deploying a lot of the infrastructure.
And to build on that comment a little bit, the designs of the drives that they want in the surveillance market are changing as well, because they certainly want to stream in from tens to hundreds of cameras into the same storage unit. So they have, or are migrating towards needs for high bandwidth, high I/O, and they're also beginning to look at starting to analyze some of that video at the edge as well. And so some of the discussion we had yesterday about high I/O devices, like the Mach 2 device that Seagate talked about yesterday, where they can move more input and output through the unit more rapidly, might be something that plays out in that market as they try to tie in more and more surveillance entities at higher and higher resolution going forward.
Yeah, I mean that's an excellent point. And think about client drives having enterprise class workloads. Right. That's a challenge that we have to that we're facing, right? So we're gonna make sure that the client drives that we are selling in this space, yes, right, are able to withstand that. Yeah,
right.
Excellent point.
Right.
Hi, question for David from Simon Sharwood of IT News and CRN. You mentioned microservices integrated into business workflows and personal streams of life. Could you explain or give us an example of such microservices? And could you explain how they'll impact on core and edge infrastructure?
Sure. I think one of the greatest examples of microservices is really about persistent authentication, right? So when you think about trying to make sure that, and I said it in my talk, but it's not just who I said I am or was, but it's I continue to be who I continue to say I am, right? So it's this security packet or the security service that follows me around, but that it provides a level of authentication that enables features of convenience. So let's say I'm walking up to my vehicle and I just came from a bar, and it shows that my walking gait isn't what it isn't normal. It shows that my blood pressure isn't normal, and so therefore when I walk up to my car, it doesn't open or it doesn't start. Right? So these are, and then I may see that as an inconvenience, but it also is a convenience certainly for the insurance agency, right? That is glad that it's not allowing me to drive that way. So I think security is one of the greatest opportunities for microservices, as it provides a level of authentication on a personal level, but even with security and for business partners and the way they access data on the go. Think about mass transit and asset management and tracking that across a geography. And again, it's providing a level of security with that vehicle or with that fleet as it goes from point A to point B.
Anthony Caruana, freelance, will write for food or money pretty much any time. I kind of want to challenge the premise that you're actually coming from about the importance of the edge. I'm listening to some of these use cases, and for example, if I take the one that Dave threw in before about microservices and a blood pressure monitor, talking to a device that stops him from getting into his car and creating an accident. That's not an edge case. That's my smartphone talking to my car. That doesn't need to go anywhere beyond the device on my wrist to my phone to my car. That doesn't need to go out to the cloud or anywhere else. So I'd kind of challenge that premise. And I'm thinking even just about the one that Jeff threw in there about video surveillance and BS threw about video surveillance. Even in those cases, the need for super low latency probably isn't there because the vast majority of the analysis that happens on video surveillance is after the fact of a crime. It's very rare that the good guys are scanning actively for facial recognition, for example, in real time, looking for people to do bad things. They tend to use it investigatively afterwards and forensically.
Well, you want to make some comments, or?
Yeah.
Go ahead. You go first.
I'll go first. So be careful on how we're defining the edge, right? So the edge is, the video surveillance camera is an endpoint. It's not really the edge. The edge, as defined in this study, is really the branch office, the cell tower is part of the edge. If you talk about telco, the telco edge is the cell tower. So think about servers, enterprise-hardened infrastructure that is responsible for data aggregation. Now, what we will find is you will find these devices increasingly embedding intelligence to take that load off the core. But if I want personalized services, right? So I want to give you if I want to anticipate your need based on your location, based on your preferences, based on the time of day, based upon your normal activity. Sure, will it get to the phone someday? Maybe, but that's information and insight that has to be calculated somewhere in the edge. And so I know there gets to be a blurry line between the edge and the endpoint and what happens, but there's a line of connectivity that needs to be established. Self-driving cars, autonomous vehicles won't rely on connectivity to do it. I mean, we just don't have 100% ubiquity in connectivity. So self-driving vehicles will in and of themselves have the ability to drive themselves connected or not. They may lose traffic information. They may lose the ability to reroute based on that if they lose connectivity, but they'll still be able to drive and provide that level of safety. So I think some of that comes into a definitional thing, and I think other is that intelligence will get pushed further and further, and there will be, you think of video surveillance cameras, they will get to the point where they'll have a level of analytics so that it knows what data to save in the camera as opposed in addition to what data that it needs to send back to the core for further analysis.
I'll comment on Anthony on video surveillance, right? Because I think what you referenced was that, well, it's more of okay, a crime has been committed, so therefore you go back and let's see what's happening and all that. I think the video surveillance of today is well, that's part of it, but what's more about it, it's more of the commercialization, prevention, and all that. So I'll give an example. Take an airport. Right, millions of travelers, coming in. Now, every single individual, every single one of the 20, 30, 40, 50 million people that pass through the airport, right, their face is being scanned every single second and microsecond. And this image that's being sent, right, has to be sent, and for it to be analyzed to see, well, who's this person? Where did this person come from, and in going to some sort of a database for these analytics. Now, this is the use case, for an edge infrastructure, because then you have to have that edge infrastructure at the airport itself, because you're not going to be able to have the right bandwidth and latency to be able to then send the image of the millions of people that you capture, up to the cloud somewhere, and then for the information to then come back down. So that's from a security standpoint. Now, if you then then look at another example, like for example, in a shopping mall. I think Dave spoke about it earlier. Imagine going to a shopping mall and immediately, right, somebody knows what your shopping habits are like. Right now, how do you get to that point? One is, okay, well, there's obviously the facial recognition. It says, oh, okay, I know who you are, and immediately I've got your history, right? Of what you've done before and what you've bought, and therefore what you're likely to buy. So these are all the analytics that are going to be required, and for these level of analytics that are required, then that's why you have to have the edge infrastructure to support that.
It's a great question. Let me give one more example.
Go
I
ahead.
promise.
Go ahead.
So this is a great example. A colleague told me. So on railways, right? What they're doing now is they're creating these. Think of it as more of a station or a bridge that goes across the tracks. That as the train passes through it, it's capturing video and data off. So it's doing a couple things. It's capturing video, but it's also capturing data that's been collected off the sensors on the train. And it's collecting all that information. It's able to identify the parts that are starting to wear, and then now if there's issues, something that needs to be replaced, maybe it's a bearing in a wheel or whatever, it is pre-ordering that part. So the next station that train stops at, the parts are already there, and the people have already been notified to come in and make that swap out. That has to have a vibrant edge to be able to accomplish that.
Yeah. And you, in your question, you prefaced your question with the comment around latency. Latency is one driver for the edge. There are other drivers for the edge, like BS highlighted, size of data, the cost of moving the data. And the surveillance example is a great example for why, not just because there's real-time analytics that he talked about, but it's also a lot of video, high-resolution video data being collected there, and it's expensive to send that all up to a main core. So they don't tend to always send all the data up there. They send a fraction or a partial or a subset of that data up there. Maybe less Big Brother-ish. I mean, in our factories at our company, we have video cameras pointed inside our equipment, and those video cameras are watching the equipment 24/7 as the equipment runs, and they're doing real-time analytics on those video images to detect if something has changed or performed aberrantly on the tool to react right away. So it's not necessarily all Big Brother. There are other elements that are driving our need for storage and analytics at the edge.
Great question, though. Thank you.